Today I will be presenting my group's findings on a real or fake job posting prediction, which was collected by the University of the Aegean. Today, the data of the real or fake job posting prediction was collected by the University of the Aegean. The employment scam Aegean dataset is composed of real-life job ads from all over the world. The purpose of this data was to provide a clear picture of the employment scam problem to the research community to find a link between all of the data collected to be able to predict future job ads. The job postings were collected between 2012 and 2014. The dataset contains 17,014 legitimate and 866 fraudulent job ads. Our data set consisted of 17,800 records, but due to issues on Weka processing, we had to condense it to 10,000. It also contained 18 attributes of online job postings. For our objectives, we want to figure out the variables and the factors and how they influence, affect, or inhibit a real job ad versus a fake one. This information is important to citizens, especially college graduates, who are looking for a job. This dataset had 18 attributes. 6 of the attributes were numeric and the rest were nominal. The classifier, fraudulent, used numbers 0 and 1 to identify if whether or not the job posting was fraudulent or not. Cleansing the data is important in being able to upload the file onto Weka and of course run meaningful analysis. We, however, ran into issues uploading the data because there were special non-American alphabetic letters and values that are not compatible with the Weka platform, specifically in the description. We decided to remove the description attribute, given the majority of its values were often lengthy and had the most non-alphabetic or numeric characters. Title originally had 6,801 distinct values, and we were able to condense similar job titles to 30 groupings. Department had 921 distinct values, in which were grouped down to 36 distinct values. The original dataset's salary range attribute gave a specific range for some postings in what salary they can expect in that position. Because these ranges were different across the set, we decided to only include the higher value range of each position, given that people are more likely motivated to get paid the most that they can in any position they apply to. Since not all companies had their profiles, benefits, or descriptions in their postings, we transformed the attribute into a nominal field where 1 represented if the posting had this information and 0 represented if the posting lacked the information. This similar nominal value representation was used on the original dataset in the telecommunicating, has questions, and has company logo attributes. Missing values were replaced with zeros and null. We used the filter method to select the top 4 most relevant attributes to classify the fraudulent attribute. Using the Select Attribute tab on Weka, we ranked the attributes, then deleted the 3 lowest ranked. After, we ran naive Bayes to run the accuracy rate of our attributes. We did this until the correctly classified instances was 95.1805%, and selecting industry, location, company profile, and has company logo as predictors for a fraudulent classifier. To find a solution, we used 5 data mining techniques we thought would give us an idea of predicting fraudulent job ads. The techniques we used include RepTree, K-nearest neighbor, naive Bayes, support vector machines, and association rules. We use naive Bayes classification to assess its performance using the 10 cross-fold validation and training set. There is a higher percentage of correctly classified instances for the training set with 95.3905%. We use the a priori method when conducting the associated rules analysis. The first results shown are for min support with min metric 0.45 and min support 0.80. The results shown on the lower half are for the lower bound min support of 0.47 and min metric of 0.90. These are the results for min support with min metric 0.50 and min support 0.80. After conducting multiple versions of a priori association rules, we found that the majority of non-fraudulent job postings included a company logo and profile description on their posts. This correlation makes sense because these are essential details in a job posting that can confirm its credibility and legitimacy. The results from using cross-validation tenfold and the user training set were significantly different. Both cross-validation and the training set used k=1 as it produced the lowest validation error rate for future classification of any new record. The cross-validation error rate was equal to 406 out of 10,001, or a 59.4% accuracy rating, and the training set error rate was equal to 356 out of 10,001, or a 64.4% accuracy rating. According to the datasets, cross-validation found 41 false positives and 365 false negatives. The training set found 21 and 335, respectively. We use the rep tree method when performing the decision tree analysis. In this rep tree analysis, two sets of testing were chosen, tenfold cross-validation and user training set, as we have performed on Weka throughout the course. Below is the output. Compared to the naive Bayes classification performance, we see a higher correctly classified instance for the rep tree method in both the tenfold cross-validation as well as the user training set. After trying Decision Tree's rep tree method and the results, we decided to try the support vector machines method. The first figure demonstrated the output from the cross-validation tenfold, and the second demonstrated the output from the user training set. Based upon the output for both of the test options, using the default parameter of c=1, the results were positive. The number of correctly classified instances were close to 100% of the data. Reported as 95.46 in cross-validation tenfold and 95.57 in the user training set, respectively. Based on the output obtained and the analysis we performed, there are findings and recommendations that can be made. We found that the SVM-SMO method was the best classifier, which produced a higher correctly classified instances percentage than naive Bayes. We found that non-fraudulent job postings also had a company logo and a company profile, which was not surprising. Our recommendations to users of this data and people looking for jobs is to be aware of the representation of the data. Pay attention to detail when reviewing postings, use your best judgment, and always make sure there is enough information provided by the employer.